Now we are going to discuss the triple product. This means we are given here three vectors A, B, and C. There are vectors given to me, vector A, vector B, and vector C. I want to find the triple product. Now again, as we are having the two vectors, and we define the scalar product, so we are having the scalar product and we have the vector product. Similarly, in this case, we are having the scalar triple product. That is the result of this one be scalar triple product. This means the result of the product will be a scalar, and we are having vector triple product. Vector triple product. So the result will be vector. We take cross product of any two vectors. I take cross product B and C, and then I have two vectors now, the A, B, and C, because cross product of two vectors is a vector. So I have two vectors A and B. Now we multiply these two vectors. Now if the result is scalar, we say scalar triple product. If the result is vector, so if we define this one like this one, A dot B cross C, so this will be scalar. We call it scalar triple product because we know that the result of two vectors when take dot product is scalar. And if we take this one, A cross B cross C, this is a vector, so we define as vector triple product. So there are two ways of finding the solution of this one. Number one is we take the cross product and then we take dot product with A. So you can say if we can have here A cross B and then we take with dot product with C, this will be also the same as we get the result this one. So we can make the definition of this that there are two ways. One is that we take A cross B and then they take the dot product with scalar triple product. We take A cross B cross C and A, and then take cross product vector. But we have the definition. Our definition is A dot B cross C is our determinant. We take component of A, this A1, A2, A3. I have here B1, B2, B3. I have C1, C2, C3. This gives me the definition of the scalar triple product, and we are having here this as a determinant made by the vectors A, B, component of A, component B, component C. If we interchange this one, we get minus sign. As we say, A cross B is equal to minus B cross A. If we are not changing this sign, for example, I change dot and cross, but the result will remain the same. If I take here A dot B cross C, and instead of this, I take A cross B dot C, the result will not change. The result will be the same. We can write like dot and cross I can interchange. There is no effect on the result. So I give you an example and explain you with the help of example. So applying this scalar triple product, we can just solve the, we give some important definition. This is scalar triple product. Scalar triple product. By using this one, we are having here the certain definition. Number one, we can find the volume of the box. So sides are the vectors A, B, and C. Their side vector. With this box we call parallelepiped. If this is a right angle triangle, then we say box, and if it's this one, we say it's a parallelepiped. This is a parallelepiped. So we want to find this one. So when we take the box, then let's say this base area. This here is our base area. Multiply by the height. This xy is the base area. Multiply by height. That gives the volume. Want to find the value of the parallelepiped? Then we having the base area. This is my x into y. Multiply by the height. Height is h. Now if we want to find this one here in this case, then what's the base area? Our base area is A cross B, magnitude of this one, or the parallelepiped. What's the height? We have the vector C. We take component vector C along the vector A cross B. What is this one? This C cosine theta. This angle is theta. This along this one is cosine theta. So this is my height. So we say my volume of the parallelepiped is equal to, I can have here A cross B, and here is C cosine theta. So I use my definition of the dot product. I can just write this one is equal to A cross B as a vector dot C, scalar triple product that will give me the volume of the box. There's one definition I just want to give you. I give you some other definitions of also that being the extension of this cross product. I'm having here the second one. are having here having here a line. This my line is line L, and I'm having here a vector point P and Q on the line, so I can get this vector PQ. Where vector R outside the line. I want to find the distance of this point from this vector. So when I want to find this one, you can see very easily. I can find the vector PQ, PR. It's my vector PR. It's making angle theta with this one. So to find here this number 2, distance of point of R from line passing through points, P and Q. Now I have two vectors. I have this vector PR and vector PQ. What's this one? This here is P opposite to theta will be PR, the coefficient sine theta. Along theta is cosine theta, opposite to theta is sine theta. So I can say here, this is my PQ, this, right, to take this is equal to the end, the distance between these two. What's my D? My D is equal to PR sine theta. What I do? I multiply this one by PQ, by PR sine theta. I multiply this one by PQ and divide by PQ. When I take this one, PR into PQ sine theta, that's my magnitude of PR cross PQ. And then here is divided by PQ. So if I want to find the distance of a point outside the line, that's equal to the cross product of this vector PR with PQ divided by PQ. Get that, give me the idea for finding the distance of a point from the line. We can change this one, PQ or PR, it's no problem because we take the magnitude. If it's negative sign become positive, so there is no problem. So we're having these two definitions. One is the volume and other is the distance of a point from the line. And with the help of this one, I would like to give you some of the examples. And before that one, we're having some properties. I just want to just mention that one here. We haven't seen this one. Number one, that we can write here this A dot B cross C is equal to A cross B dot C, same. Number two, we can define our A cross B cross C is the vector triple product. This is equal to A dot B and dot C into C, A dot C into B minus A dot B into C. Whereas, as I told you, there are two definition ways. Take the cross product, again take the cross product, or take the dot product, multiply B, take the dot product, C. This is a vector. Number three, we have the distributive law that we having here A cross B plus C. We can use this one as A. We take an example. We are given, we want to find the volume of the box having adjacent sides AB, AC, and AD, where A, B, and C are given. Adjacent sides are, they are meeting at a point. Then we say these are sides are adjacent side, and we can complete the box or the parallelepiped. We're having here, this is the base, and then we are having here the other sides of the box, and this is my box. So I want to find the volume of this box. To find the volume of this box, I define my vectors AB, AC, and AD. AB mean this B minus A, 3 minus 2 is 1, 0 minus 1 is minus 1, 2 minus 1 become 3. Then AC, this is 4 minus 2 is 2, minus 2 minus 1 is minus 3, 1 minus 1 become plus, become here 2. AD is here 5, minus 2 is 3, minus 3 minus 1 is minus 4, and 0 minus 1 is plus 1. So this is my vector A. I can define this one. This is my vector A, and this is my vector B, and this is my vector C. So what's my volume? My volume is equal to the magnitude, the absolute value of A cross B dot C. Why take absolute? Because volume is always positive. So I can take here my components of A, B, and C. This here is by taking my definition here. This is the the component of A, then component of B, and then component of C. Component of A are 1, -1, and 3. Component of B are 2, -3, and 2. And component C are 3, -4, and 1. We solve this determinant, and the value of this determinant is -4. We take absolute value, and this here is 4 units cube. So this is the result which I get here. As I mentioned that we are having, this here is not minus, it's plus, so it's remain plus, and 4 units. We having the absolute value. We can just rewrite this one, and we are having here solution of this one is positive. If this negative, then we can just take the absolute value and make it positive, because our volume or our area, they are always positive. This one example. Given an example, we take this example. We want to find the distance of the point P from the line, and this line contains point Q and QR. This point P is here. So we just make it that if I want to find distance D, we say this angle is angle theta. So now we can find this is what is. This is our distance will be QP absolute value sine theta, the sine component of that one. And we derive the formula for that one. We take the cross product of QP with QR divided by the magnitude of QR. So that means we need two vectors QP and QR, and we take the cross product and we can. So I solve it. So we having the vector QP. QP vector is equal to, this here is P minus Q. This here 3 minus 2 is 1. Then we have 1 minus 5 is minus 4. And then we having here minus 2 minus 1 is minus 3. And then I having vector the vector QR. Now my vector QR is R minus Q. This minus 1 minus 2 is minus 3. Therefore, minus 5 is minus 1. And 2 minus 1 is 1. So I get this vector. Now I want to find the cross product of QP and QR. QP cross QR. We take cross product of this one. These two vectors. So by our definition, this is I, J, and K. Then component of QP is 1, minus 4, and minus 3, and QR is minus 3, minus 1, and 1. Now we solve this one. I'll get the value of this one is equal to, minus 7I, and then I'm having plus 8J, and then we are having here for K, we are having minus 1 and minus 12, minus 13K, minus 13K. This I have shown you before, so that's why I'm just skipping this one, writing every time. Now next is we want to substitute in this formula. We need the magnitude of QP, QR, QP cross QR. We take magnitude of this one is equal to root of square of this one is 49. Square of 8 is 69, 64. And so 169. We add it, we get here 284, 282. So this is my magnitude QP. Now I divide it by the magnitude of this one, QR. So QR, we take magnitude of this one, that is equal to root of, we are having here this vector QR is 9 plus 1 plus 1, and we get here the value is equal to root of 11. So I can write my result. My result will be equal to, my D is equal to, I put the values, is equal to 282 under the root, or 11 under the root. We can combine this one, get here 282 or 11 units, because it's the length is in terms of units. So that's the answer of our problem. You can solve this one, and the value of this one is approximately equal to 5.09 units.